Hello, protocols, packets, and programs. Welcome to October, when tales of terror become timely and the days take a fearful turn towards Halloween. I'm sure anyone could name a few horror movie tropes. They can be entertaining, but they're often predictable and just a bit unrealistic, like a cabin in the woods, an abandoned medical building, or software written in C. Which means, this week, we chat with Scott Piper about the complexities, configurations, and challenges of cloud security. Grab a flashlight and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly.
On the Security Weekly News, I try to scan and produce a quick look at some of the major stories to help you keep up with what's going on in and around the industry in a short format. Myself, Aaron Leyland, Josh Marpet, and other guest commentators provide greater insight every week. I'm Doug White, and I hope that you'll look for the Security Weekly News in all of your favorite podcast catchers and subscribe for the latest content.
This is episode 304, recorded October 21st, 2024. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John. I'm going to ask again, and this time I'm going to say, hello, John, have you unmuted?
You know, how long have I been doing this? We were just talking off air, 300-something episodes, and I still can't unmute my microphone.
We would much rather have you unmuted and get the raw, unfiltered John Kinsella. Thank you for joining us. We also have Kalyani Pawar, who's possibly also on mute. Let's check. Kalani, hello.
Hello. I'm off mute now. Giving my unfiltered opinions, starting now.
Unfiltered opinions starting now. We also have an unfiltered guest that I'm looking forward to talking to. It's Scott Piper, who works on Wiz's threat research team, where he analyzes risks within AWS environments. Prior to that, he worked on security teams and as a cloud security consultant. He helps organize the Forward CloudSec conference, administers the Cloud Security Forum Slack, and maintains a number of resources in his role as the Internet's cloud security historian. His more popular projects are the open source tool Cloud Mapper and the CTF flaws.cloud. Hello, Scott. Thank you for joining us.
Hi. Thanks for having me.
So the first thing I have to ask is there's flaws.cloud, there's flaws2.cloud, which makes me wonder, do you use the same naming scheme for your passwords?
No, do not use the same naming scheme there. Yeah.
Okay.
And I realized after registering 2.cloud domains, which each cost about $30 per year, that I should start using subdomains or some other solution as opposed to buying new domains for projects.
Domains are fun to collect. They're just like Pokemon. Yeah. But we'll come around to the CTF and learning about cloud, because I think those are pretty fun. But before we try to get you to divulge your password, there are a lot of complexities. There's a lot of challenges that people encounter when dealing with the cloud. And this is, I guess I want to kind of do this from the perspective of people going cloud native, starting off from scratch, building, I'll say hopefully in capital letters, the right thing within the cloud. How hard is that to do these days? We have, I want to say modern cloud. Cloud's been around for a decade. You're a historian here. Walk us through a little bit of what the journey looks like, and are things much better today?
Yes, they are better, but more complex. And so I'll dive into that a little bit. So the cloud started a little more than a decade ago, and, you know, I focus entirely on AWS, and they were the first major cloud to come out. And so I'll talk about that a little bit and how things have changed there and gotten better there. So when it first came out, the only way in which you could access the cloud was through a single user account. So username, password, and everybody on your team shared that same username and password. There was not the concept of IAM at the time. There was not the concept of what nowadays we have is users and roles in AWS. And so you had a shared access key as well. And so all these things shared across all these people. So you have no idea who is taking what actions. This is all powerful. There's no way to limit the permissions or privileges of it. And so as a result, things have improved a lot there. So we got IAM users. So now you could have different people on the team with different passwords to log in. So if, somebody left the company, you could, revoke their password, revoke their access. You had, ability to limit privileges in different ways. But you still had, with IAM users, you had these access keys that never expire. They live forever, and so then eventually we got IAM roles, and now that's what we're using today. So in general, yes, some things have gotten better. Some of the initial, kind of things that made sense at the time, things that were the minimum viable product at the time, they have improved. But now there are so many different AWS services. I think there's over 300 different services on AWS nowadays. So there is I focus only on AWS, and I can no longer say that I'm an AWS expert. I'm an expert maybe-ish in some areas to some degree, but there are services I've never even used before. Some services that, it's oftentimes, a kind of joke or challenge people play against other, cloud security experts is you name an AWS service and see if the person knows whether or not that's actually a service or if you just made up a word. So it's gotten very complex.
Even on that aspect of IAM, we'll try to get into the other 299 services out there. We'll see if we have time. But on the IAM, that can get complex and surprising too, because it's not like a Unix world where you have read, write, execute. You don't just have root, non-root. You have a lot of interactions that people can also get tripped up on. And, in the spirit of complexity, are there some particular surprises that you always are like, oh, don't do this one mistake, or here's a particular pattern to follow because, a year from now, you'll really appreciate how you set yourself up for success?
Oh yeah, I mean, we could do a whole episode on just IAM, but yes, there are a number of gotchas within it, and one that immediately jumps to mind is there's differences in the names of the privileges between what you specify in your IAM policy and what actually gets recorded in CloudTrail, or what APIs you actually call. And so there can be naming differences there. There can also be there's not a one-to-one relationship mapping between the IAM privileges and the actions that you call. So there are some actions that require multiple privileges in order to be able to make that call. And so yeah, it is a very complex thing. As opposed to the Linux world where as you mentioned, there's read, write, execute privileges. There are. So there's 300 services. There's over 10,000 different privileges that exist on AWS, and those have different conditions associated with them. So yes, very complex. And so I want to say to try and before people's heads explode from all this complexity, my biggest guidance to people is to advocate for and make it easy to have multiple AWS accounts, because between AWS accounts, you have very strong isolations. So if somebody has full admin privileges inside one AWS account, generally speaking, there are some maybe exceptions on how you can configure things, but generally they're not going to be able to interact with or mess with another AWS account. And so, historically, a number of years ago, big companies maybe had dozens of AWS accounts. That was maybe big. Whereas, nowadays, there was a talk by Amazon's retail business at reInvent, which is AWS's big conference, and I think I can't, this was a couple of years ago, but they said that they had over 10,000 AWS accounts. And so those are now the big numbers. And so the concept of encouraging account proliferation is something that I strongly advocate for. And it solves a lot of different problems. It solves not only those privilege problems, but it also solves problems related to ownership and trying to identify who is responsible for fixing something, who is responsible for the cost of something. Because on AWS, the other way of trying to solve that is with tags. And so the idea that you would try and tag things, say, I'm the owner of this, and that becomes a mess in all sorts of different ways. Whether it's different actions not supporting tags or supporting them in different ways between different services. The names that you use for a tag, like, should I call this the owner? Should I call this the team? Should I associate this with an email address or with my, full username, or all sorts of different complexities there. So having multiple accounts is something that I think has a lot of benefits.
And it just points out too, that last part is just describing the classic problem of asset inventory, that it does feel like, I like to think that the cloud at least makes it easier to discover, but then we do get our fun phrases like shadow cloud, things like that. So have you seen, I like to joke, AWS, GCP, Azure, they have wonderful asset inventory because they know what to charge you. You were talking about, managing costs.
Yes.
But organizations, can kind of lose track on that. Is there ways to keep that relatively corralled? Because just having 10,000 accounts, let alone, we haven't even talked about buckets or instances yet, sounds kind of worrisome.
Yeah, so a couple ways to attack that problem. One, going back to like the encouraging the account proliferation process. So I refer to this as account vending. And so I had a recent blog post on this last week where I talked about how I encourage this. And the concept there is really to make it easy for people. I think one of the things that security has tried to advocate for in recent years is to not be the team of no's, but to be the team of yeses, and to make the right way easier for people. Because if they go down what you think is the right road, and you make that road easy for people to walk down, then that's going to be the path that they take, as opposed to trying to create their own path. And so this also brings in the concept of paved roads, which is also a concept in the cloud where you are generating, where the security team is perhaps involved in the creation of modules for people to be using that are already pre-configured in the right ways, doing the things that not only do things the right way, but make it easier for your developers to stand up those resources. So I guess making it easy for people to do things the right way. But then as a more, I guess, like tactical thing that you can do today in terms of reducing that shadow ID is you want to talk to your finance team to figure out who is, getting Expensify reimbursements for their AWS account, who perhaps has like a separate contract in some way. So you can do that. You can, if you have the ability at your company, to search emails. So this is something that, European companies tend to not be able to do, but in America, their security teams oftentimes have the ability to search the emails of their employees. And so looking through those emails for basically welcome to AWS, so somebody has created a new AWS account. Right. So being able to do that, you can reach out to your TAM at AWS, which is basically your point of contact at AWS. And so if you're a large enough company, you have an individual there that you can talk to, and they have some solutions as well that can help you out to identify, what AWS accounts exist at your company.
That actually sounds, it's a gnarly problem, but those actually sound pretty feasible solutions and relatively scalable solutions as well. So I will say I'm developing a sense of optimism here. Yes. I want to see if I can continue this optimism, because you were talking about paved roads, and this is, famously Netflix went all in with the cloud. They launched a lot of our discussions in general in the industry about paved road, guardrails, et cetera. But, and this might also, maybe Kalyani has some thoughts here too, but how do you get those paved roads started? Because if you're just talking to the development team, like, hey, rather than just setting up everything for this feature that we need to launch, make sure you set up all of the, picks and shovels to build this feature right in the first place. And then a month later, you can get to what, the product manager was expecting.
So one way, I guess, is to look at what has already been done. Like, what are some common themes? Like, if you go out and talk to the developers, find out what are they creating oftentimes, or, this could be also like, where are the areas in which we're commonly having misconfigurations? And, these are the things we're constantly asking people to fix. Like, is there a better way of trying to do that? So those are some of the things. Also, if you have, new strategies, new plans of doing things, so maybe historically you've heavily leveraged using VPNs, and now you're going to start moving towards a zero trust model, and things are going to start being publicly exposed, but it's supposed to be protected by an SSO login. Well, that SSO login aspect, you want to create some type of paved road, so that it's easier for people to stand up that SSO protected resource in some way, so they're not having to figure that out on their own.
Talking about paved roads, I wanted to ask real quick, what is the most common and bizarre bottleneck you've seen with respect to setting up paved roads? Because I'm guessing in terms of making a fast-paced product, we often give up on certain conditions for security, right? So what's the most bizarre thing where people maybe went behind your back and then just made something?
So I guess the biggest kind of issue is, as I alluded to, is that you may want to create these paved roads for things that are already being created inside your environment. And that means that you are retroactively asking people to backfill in something. And that is always problematic. It makes sense that, hey, this is a thing we're already doing. This is a common thing. We should make this easier for people. But then all those common things, you need to now ask teams to go back and switch and make better in some way. And as you try and do these types of things, you're always going to realize people are doing weird things. It sounds weird to you until you talk to them and you realize that there's a totally reasonable, excuse for doing things the way that you're doing it. And so those are things you have to keep in mind is, you oftentimes, as you interact with different teams, you start realizing that they have very specific, very niche reasons for doing things. And so even though you're oh, we'll make this paved road, we'll make it the same for everybody, sometimes you have to have some flexibility there and make it, accessible for people to modify it.
So in terms of, we can call this security debt is also tech debt, right? And then in regards of that, we just spoke about, this looks unreasonable on the outside, but then you talk and then you're oh, it seems fairly reasonable. I'm curious if you had some interesting examples to shell out where, people were maybe not SSOing on a publicly exposed endpoint or something like that, a nightmare.
I think it just comes down to, you may have some preconceptions in your head about what is the purpose of, for example, an S3 bucket. What are people going to do with that? I'm going to make a paved road for people to use an S3 bucket, and then you realize oh, well, S3, it can be used for all sorts of different things. You could use it for backups, in which case, that's a certain use case. You could use it for a CDN, in which case that's a specific use case. You could use it as part of a queuing service where it's just short-term storing things, but those objects are too large to store inside your queue, and so you're going to keep it there. And so I think that's where you start realizing oh, S3 is actually incredibly complex. It can be used for all sorts of different things. So I think that's one of the big challenges there.
And one of the things that you also kind of mentioned in there too, that Kalyani was, I think, also triggered here, is that idea that there's legacy systems there. You can still have legacy in the cloud, because even if the cloud's been around for 10 years and early adopters, that IAM story possibly change, as you gave us a great example of that, from the beginning. There's also even just examples of something as simple as IMD, if I can get it out correctly,
IMDS V2.
Yes, exactly.
V1 and V2.
V1 and V2. And part of that too is that, is sort of these known issues. SSRF can be well abused with V1. And there was the idea of, well, how do cloud providers create a CVE for this? How do they talk about these vulns? Because a lot of these vulns, they can actually fix themselves, but there's the catch. They'll say, we fixed this. We looked at our own logs. We didn't see any evidence of compromise. But it just so happens we fixed this from this point forward. We're not going to muck about with, I think for good reasons, your existing systems that don't have this. So when that comes up, I do want to talk about the cloud vulns more generally, but how do you approach this legacy aspect as well?
So that's always a challenge, because you have these systems that the people that stood them may have left the company. You may have lost knowledge about how this thing works, or even how to deploy it. It may have, like, the initial creation of this thing may have been click ops, where people were just clicking around. They weren't using infrastructure as code, or something that was actually stored in a GitHub repo where you can make changes and automatic deployment and like all those nice things that you hope that you have. Like, chances are, especially the legacy, it's like, well, your company was a startup at that point in time, and people were just trying to, like, have the company survive and doing things as quickly as possible, all the wrong ways. But it was like, we'll get back to these problems later, and now is later. And so you have to fix them at some point. But yeah, I mean, I think generally there are problems not only in cloud security, but all security, and this probably moves into other areas as well, outside of security. But like, how do you motivate people to fix a thing, to do a thing, to get something changed? And one of the ways is, again, those paved roads of making it easy for people to do the right way, to try and make it as easy as possible for people to switch over to something. But then you also, sometimes you may want to, prove why this thing needs to be done, like actually show them. And sometimes, that may take the form of like a bug bounty report or something like that, in which case, like, it becomes very strong encouragement to get on that and focus on that issue. But there, yeah, I guess, trying to get people to make these changes inside the environment. I think you also, for yourself, you want to try to make things easier on yourself. And one of the things you want to do is, collect metrics on these types of issues, like as you're going through, as you're starting. And, this is not only good from the perspective of like ensuring that you have made the right choices in how to solve this problem, because if you notice this problem is getting worse instead of getting better, then you may need to change tactics in some way.
Fair point.
But also, in all honesty, like, it's good for, your promotion packet if you can, provide numbers on how bad a problem was and now how good it is, in some way. So that's something to look at. Looking at how you can apply ratchets. So the concept here being like, is there something you can do so that things are going to move in one direction only? So like a ratchet strap is something that will only tighten. And so in AWS, there's a concept of service control policies. And so with this, the idea is basically you can block things from happening inside your environment. You can prevent people from taking certain actions. And if you apply these SCPs, you can basically ensure that nobody is going to make this problem worse. SCPs are a tricky thing to deploy because they are only in one direction. You can try to add some exceptions and do some things there, for the cases where people need to still be able to do it, but it becomes complex and frustrating for your developers especially. And so going back to one of the original points, like if you do make things painful for your developers, that's how you get shadow IT, because they start working around it. They create their own AWS account in order to avoid those like service control policies or other blockers that you've implemented.
And even in this IMDS v1 example, it's not so simple. I love the idea of the ratchets, but it's not so simple as just start turning this on, because your experience with this, you discovered some edge cases, some interesting scenarios that I wouldn't even thought of. Tell us a little bit about this journey to get to, what does your promo packet look like to get from V1 to V2? How did you affect that change?
So one of the things that had surprised me when I had tried doing this for a company was all of the vendors that we were using, and those vendors that did not work with IMDS v2. And so this then forced me to have to reach out to those vendors and encourage them to fix this. And also one of the problems is, you have maybe one set of vendors today and you get those vendors to fix things and you've deployed these ratchets, and then somebody for whatever reasons decides that they want a different vendor. And now you have to go through this process all over again with a new vendor of trying to get them to fix it. And so that was one of the things that I ran into. I had created this wall of shame, a public wall of shame for some of these vendors. And this was the strategy I had chosen at the time. I don't think I would choose that same strategy again. This was only a few years ago, but I feel like, I was younger and less mature then, but kind of lesson learned there. And the reason for it being is, so I had gone in with the assumption that this is something that these companies should have known about for a number of years. So it's not like I'm disclosing a 0 day to them that I just found and give them the whole 90 days like to fix it or something. This is something that they've known about for years and they haven't done anything about it. And so wall of shame, and just put it up there, and now hopefully this will encourage them. But obviously that's kind of a jerk move to go that route. So I regret having done things in that way. I should have probably gone through like the normal report a bug, ask them, for 90 days, ask them for, progress reports on it, and then, threaten them with disclosure as opposed to just going to disclosure. But it's also a problem where it's not. It's one of those issues that, as we kind of mentioned, like it's not a problem where it's immediately going to get you owned. You're not going to be hacked from this directly. There have to be other things that go wrong. And there's no CVE associated with this. There's no easy identifier for this. And so as a result, it's more difficult to encourage people to fix some of these problems sometimes when there isn't, when it's only a misconfiguration. And sometimes some of these types of misconfigurations, like they're not a misconfiguration for some people, but they are for other people, with some of these different features and functionality. And that becomes especially difficult to try and encourage people to change, to do something different, and so I guess hopefully that kind of answers the questions on some of the difficulties
it does.
involved.
No, thank you. That's a good transparency and some honest sharing there, because as you say, there wasn't a CVSS score like this is a 9.9 or this is a named vulnerability that we can scare people with. Speaking of Halloween things, but let me also throw the other side of the coin there, Scott, because just so our listeners know, you have matured and you have gained wisdom in your years. And there was another story about a community success story, I think, between GitHub Actions and AWS. So tell us about this new journey.
Yeah, so this one, so this is basically GitHub Actions. There's an integration with AWS IAM roles through this mechanism called OIDC. And what was happening, three different teams of researchers all kind of found this issue at about the same time. And that's kind of a whole other story about how there's kind of the same concept of like twin films that impact security in the same way, like the movie industry comes out with like multiple films that all have kind of the same plot at the same time. Sometimes in the security industry, like multiple people find the same vulnerability or same type of problem at the same time without talking with one another. So anyways, three different research teams identified this problem, identified a number of victim companies, reached out to those victim companies to fix the problem for themselves. And I decided to get involved with this issue as well, from the perspective of trying to encourage the different entities involved who could make changes to try and eradicate this problem. So you have basically, you have GitHub, you have AWS, because that's where the integration is. You had HashiCorp because they produce Terraform, and Terraform has a quirk associated with it that was relevant to this problem. So I guess to try to quickly describe it, if you create certain types of JSON in Terraform, and you want Terraform to interpret that, and you have a dictionary that has multiple keys with the same name, you would expect that it should throw an error saying that you have multiple keys with the same name. This is invalid JSON. Instead, what happens in Terraform is it silently ignores one of those keys, and so this was also involved in why this problem was occurring. And so you had those entities, and then you had some tutorials online as well that were encouraging or basically showing you how to do something, but it involved this mistake in it. And so as part of this, what I did was reached out to the author of this tutorial that included this mistake in order to get them to fix that. So that should hopefully reduce the number of people that are copy pasting things. I created a honeypot to try and see are attackers actively exploiting this in some way, in order to try to get statistics and something to further advocate for this being a problem. I included some information on a Terraform issue in order to specifically call out why this was a security problem, because historically people just said, hey, this works differently than I expected. And so I included information on there to basically say, this is impacting people's security. Here's some examples of where, people have identified that this has been problematic for them. So I did those things, but then the bigger things was reached out to AWS, and I've interacted with AWS for a long enough time. I know how they do things, that I know what were the places in AWS where I could basically encourage them to make certain changes, because it's one thing for AWS to be aware of this. It's a different thing for any company. When you reach out to AWS's security team, that then puts you in a different path or pipeline than just writing a blog, because now they've received basically information that they are being asked to fix something, and you are reaching out to the team that is responsible for fixing things. And so that's an important thing to do. But then also making specific asks to them about what they could do. So what I asked them to do was, in the AWS Web Console page, when you are clicking around and you are making this integration there, to basically, if this integration is going to be with a GitHub action, the AWS Web Console would then basically ask for some additional questions in order to ensure that people were not missing this certain condition that they should be using there. And I'm not sure if I actually mentioned what the main problem was, but the main problem is that any GitHub action could potentially assume into somebody's AWS account through, basically, you were making this AWS IAM role that was public to any GitHub action. So if you missed this condition, instead of being restricted to only your repository, your GitHub actions that are within your GitHub repo, any GitHub repo could create an action that could assume into your role there. So I should have said that from the beginning there. But yeah, and so also asked AWS to email their customers that were impacted by this. I do work at a security vendor, but AWS, they have all AWS customers as customers, and so they're able to reach out to everybody in order to request that they fix that. But then HashiCorp, they issued a security bulletin as well for this issue. And then finally, AWS actually decided to enforce restricting this from happening. So they actually now, if you try to make this integration in the insecure way, AWS will actually block you from doing that. So finally, they applied the ultimate ratchet on this. So anybody with the existing problem, they still have the problem. AWS isn't going to change how you've done things, but from here on out, nobody can basically do that bad thing anymore. And so that was, I consider to be like a success story where, here's a problem that was a problem for many companies, shown from researchers that there were many victims, and now it is no longer a concern for people. Like it is now blocked, so you don't have to worry about this one anymore.
And it also sounds like a very common security journey that is reminiscent or recognizable, not just to this one particular instance. And what I mean by that is changing documentation so that people aren't just following blind documentation, doing the wrong thing out of ignorance, naivety. Then doing the customer outreach to say, hey, there is a problem. Here's the name of the problem. Please make a fix. To ultimately a better secure default, like you're saying, how AWS landed on just enforcing. So
exactly,
if we can shorten those times between, documentation, a good UX of guiding people and asking those extra questions and getting into that secure default enforcement when it makes sense, we would possibly be out of a job, but I'm sure there's going to be other types of things that come up. I don't know.
Exactly.
But, for those of us, or for those listeners out there who want to maybe explore a few hundred of these AWS services from a CTF perspective, tell us a little bit about flaws.cloud. How much experience how much of an expert do they need to be to start playing with that CTF?
Yeah, so flaws.cloud, I created it in 2017, and I have not updated it since then, really. So it still forces you to use an HTTP page, not HTTPS, which is, so I did this on purpose, though, because the way in which a public S3 bucket works, which is, I'm giving it away, that this is one of the levels is a public S3 bucket, but the way in which a public S3 bucket works is it only works as a public HTTP page. And so I kind of was forced to do that a little bit, but yeah, and then I just haven't updated it. But all these problems still apply. We still find public S3 buckets that shouldn't be public anymore, even though AWS has implemented a number of improvements, as we mentioned. That it has improved a number of ways. There is now much more friction than there was historically to creating public S3 buckets. But yeah, you can. You can play the first 3 levels without maybe first 4 levels without any AWS account whatsoever. And then from there, you will need your own AWS account for one of the levels. It won't cost you anything to accomplish this thing, but you do need your own AWS account for that. But yeah, it basically just gives you access to my AWS account, and that is vulnerable to a number of issues. It was terrifying when I first created this about even though I'm I think I know AWS security pretty well, but I'm giving any random person a AWS access key with more privileges than most people expect, normally. Am I opening myself up to any concerns here? But yeah, so it gives you that access and you can play around with it. Flaws 2 then gives you both a attacker and defender perspective. So there's some new levels which take into consideration some new types of services there, and then has kind of a defender path to show people how to investigate logs a little bit on AWS in order to understand what is kind of happening behind the scenes when an attacker does these types of things.
Thank you for that overview. And my one last comment, Scott, will be we're in the season of Halloween movies that have lots and lots of sequels, and we need a lot more than just Flaws 2. So hopefully you have some time to work on some more.
There are some related CTFs at my employer, so we have a number of them that are out there. They're also free, and so there's ones for one for prompt engineering, Gen AI. There's some others as well. They're also fun.
Prompt Airlines is pretty fun. Well,
yes.
I think we've mentioned those a couple months in the past, but we'll throw them into the show notes this week just to let Scott go work on Flaws 3 for a while. But I have to say thank you very much for joining us, Scott. This was a great conversation. Really appreciated it.
Thank you.
Well, I'll say thank you to Kalyani and John as well, and thank you to everyone who's been listening. We're going to take a quick break now and return with news of the week.